Welcome back, you guys, to Mr. Vandrick's stats class. We're going to be doing quiz A today. Before you start this video, go ahead and like and subscribe and put on the notification bell. Okay, let's get started.
Excellent. Very good. Wow. Well done. All right, let's do this. Okay, so in this first problem, we have some information about a professor and how many emails the professor expects to receive on a given day of work. You can see we have 0, 1, 2, 3, 4, or 5. Those are the options. Okay? But you can also see that it's not equally likely that his professor is going to get that number of emails in a day. All right? So how do we find the expected value? How do we find the expected number of emails that this professor is going to get in a day of work? Before I add them all together, I do what? Multiply what?
0 by the power.
Very good. So multiply your possible options, your possible number of emails, times the likelihood that they will happen. All right, so I have 0 emails. And how likely is the professor going to get 0 emails in a day from students? 0.05 plus 1 email from a student. How likely is that to occur? 0.1 plus 2 student emails times 0.2 plus 3 student emails times 0.25 plus 4 student emails 0.3 and finally plus 5 student emails. Whatever all that is will give you the expected number of emails on a given day for this professor. Again, from students. Oh, you good? I got you.
Okay.
Thank you, though. Now, the reason I'm passing out these calculators is because when you get to the next question that asks to find the standard deviation, it's going to be a little easier to do that with these calculators. Excellent. Anyone have an answer yet for the expected number of emails for part A? Anyone? 2.95? What's the units? Emails. Very good. Now, I'm not sure how familiar you are with emails, but I know I've never received a fraction of an email. So to see 2.95 emails, I know right away that there's no day that the professor is going to get 2.95 student emails. That's not possible. It's going to be 2, 3, 4, 5, 1, or 0. All right, those are the options. All right, but why are we okay with that number? Why are we okay with it? Because it's a statistic. It's not an actual value. We know it can never happen. It's the average. It means if I looked at a whole year of this professor, and each day I said, hey, keep track of how many student emails you get. And I took all those numbers that the professor gave me, added them up, and divided by the number of days the professor worked, I should see a number that's close to 2.95. All right, that is the average. Questions? All right, let's try letter B. When I see a question asking me for the standard deviation, the first thing I think about is I need to find what? What do I need to find? To find standard deviation, I first need to find what? Not the mean. We just found the mean. Close, not variation. The variance. That one, exactly. The variance. So VAR stands for variance. all right, which is a measure of spread, but we're going to see what variance, the reason we don't stick with variance at the end is because variance always has squared units, and we don't want squared units. Okay, so let's do the first one. The professor gets 0 emails, let's say, minus, what is the average number of emails the professor gets in a given day? 2.95. This is called a deviation. All right, whenever you see that subtraction, that's a deviation from the mean. What should I do with all of my deviations? Square them. Very good. Should always square them. All right, are all of these values equally likely? They're not. So what was the likelihood the professor gets 0 emails from students in a day? 5%. So I'm going to write down times 0.05. What I want you to do, if you can do this for me, try something new. When you write it down on your paper, the moment you finish writing out this one, write it in your calculator. Like type it in your calculator. That way we can do it as we go. And like you don't have to hit enter, I just mean like you're starting it. Does that kind of make sense? Maybe? Like, do you see what I wrote up there in orange? Minus the, obviously don't do the variance part. Type this into your calculator right now. Don't hit enter. Like leave it in, like you're going to start doing it.
So why do we only multiply like 5%?
Because the 5% is connected to this 0, which came from my probability distribution table. All right? Plus, the next option is 1. 1 email minus the average of 2.95. Square it. Times, what was the likelihood the professor gets 1 email from a student? 0.1, 10%. Now again, I want you to write plus and type that in. I'll tell you when to hit enter. Don't hit enter yet. Plus, I'm going to move a little faster. 2 minus 2.95 squared times 0.2 plus 3 minus 2.95 squared times 0.25. When you get done with the 3, like all of this one, then I want you to hit enter. And let me know what you get when you hit enter for what's written up there so far. 4.9? Is there a bunch of stuff after it? Confirmed? No. 0.99? I would say so far, if I got 3 people that say 0.99, and I see Sabrina has 0.99, it's okay. I'm not saying you didn't. I'm just saying maybe there was a mistake. It's all good. 0.99? No. Yeah. Good job. Now don't clear anything. The reason I had you hit enter is we're not done. The calculator can't go past that. For some reason, when we tried to do this earlier, it wouldn't let us keep typing more. So we had to pause. You hit enter. Make sure you arrow down. We're going to do a new line. Okay, new line. Or plus, that's fine, just hit plus. Plus 4 minus 2.95 squared times 0.3 plus 5 minus 2.95 squared times 0.1. And then you should be able to finish it off. Let's see what people get for this one. So you already had 0.9965. And you're adding these last two. Say it again. I'm hearing 1.7475. Confirm, anyone? Uh-oh, Sylvester. 1.7475. Uh-oh, Sylvester.
I feel like I'm supposed to do something.
What'd you do?
Did we square that?
We haven't squared that yet,
Okay.
or done anything to it.
Okay, I was
Yep.
like,
Excellent, Adriana. Okay, so I'm going to write down 1.7475. What are the units? What are the units?
square.
Very good. Squared emails. So that's the variance. So how do I find the standard deviation? Very good. No, Jalissa, you're right the first time. The square root of 1.7475. What is the square root of 1.7475?
1.321.
So 1.32, we rounded?
Yeah.
And what's the units for this one now? Emails. Very good. That is the standard deviation. Man, that was fun. Woo! It's exciting. Can't wait for all the views. We were recording, yes. Now, a couple of things I want to say about that number to give you a little perspective here. I had a student in a different class get a little confused by this number. This is just a measure of how spread out this data is. Do you see how our data values go from 0 to 5? So our standard deviation is fairly small. All right, just over one email. What if instead of these numbers being 0, 1, 2, 3, 4, 5, it was 0, 5, 10, 15, 20, 25? Then what would happen to this standard deviation? It'd be bigger. It'd go up. All right? The further spread out your data is, the larger your standard deviation is going to be. Okay? It's a measure of how spread out your data is. All right. Let's look at part C. I know I kind of wrote into part C. I apologize. Let's look at part C. It takes the professor an average of 10 minutes to respond to each email from a student. Man, that's a long time. I like to use Google when they just like pop up that says like great thanks. I just click it. I'm all about those. All right. So when you send me emails and you get great thanks, just know I didn't type it. All right. But I mean it. I mean it. Okay. 10 minutes to respond to an email. How much of this professor's day will the professor spend responding to student emails? So we're saying on a typical day, it takes the professor 10 minutes to respond to one student email. On a typical day. So you're saying, why are you saying 15? You're using the wrong number, but the right idea, Julissa. You use the 2.95, because how many emails do we expect the professor to get on a given day? 2.95. 10 minutes per email?
Like 30 minutes.
There you go, like 30 minutes. We got it. 10 times 29.5 gives us 29.5 minutes. Or as Yasmin said, like 30 minutes. Yes, Randall. Oh, because I can't write. Might be. I got so excited just to write 29.5. I wrote it early. Might be. Yes, Julissa. Good question. The 2.95 is your center, your average. This is the number of emails we expect the professor to get on a typical day. All right. The 1.32 is how spread out the possible values that the professor can get. Because the professor can get 0, 1, 2, 3, 4, or 5 student emails a day. All right. So that range, if I look at it over a year, I expect the spread of it to be 1.32 emails. All right. So really, it's just a way of saying how far. Let's say on Monday, the professor gets 4 emails from students. Tuesday, 3. Wednesday, 1. Thursday, 5. Friday, none. Okay? So if I look at those 5 days, how spread out each day is from the average gives me the average spread of my data. All right? It's weird because standard deviation is actually an average, but it's the average distance from our data values to the mean. Everybody good with the professor? Questions on the professor? Okay, let's move to number 2, the American Veterinary Association. Anyone going to be a vet in here? Any vets? No vets. Wow, I've had 0 vets all day. Who's going to take care of the animals, guys? You wanted to? You don't want to anymore, then? Okay, well, I guess it counts. All right. Now, you can clearly tell this problem was made many, many years ago, because if you own a pet, the average medical care cost for 1 year is probably more than $100 for a dog. That's quite low, right? Just to go to the vet that we go to is $50 just to get in the door, right? Exam, $50. All you do is feel around on my dog just to make sure everything's okay. $50? Okay. Thanks for that. Like when I go to the dentist for my kids. My daughter has 4 teeth. She's going to go to the dentist next month. $180. Okay, thanks for that. Should have been a dentist. All right. What is the expected value for the annual cost for a person who owns a dog and a cat? And I'm talking about just their medical costs, right? I'm not talking about food or anything else like that. I'm talking about just to go to the vet, to keep them healthy. It's close. It's not 200. It's 220. Because for the dog, it's $100. And for the cat, it's 120. Those pesky cats costing more gives you $220. Okay? Questions on finding the expected values? Now, when we look at the next one, find the standard deviation for the annual cost that it will cost this person to take care of their cat and dog. Whenever I see find the standard deviation, my head goes crazy with that I should use what? Variances. You guys got it. So I want to do the variance for a dog and a cat. Now, yes. So what do students want to do in my class? Students want to take 30 and add it to what? 35 and get $65 for the standard deviation. And that's wrong. All right? Because we always have to think about the tattoo on the inside of my left bicep. Variance add. You add the variances, not the standard deviations. You add the variances. Okay? So what's the variance for the cost of owning a dog for the healthcare? The variance. Their variance. Their variance. What's the standard deviation for the dog? 30. So the variance is 30 squared. Plus, what's the variance for the cat? 35 squared. We're starting to get it. What's 30 squared plus 35 squared? 2125. And what are the units? Squared dollars. Squared dogs and cats. That was good. I like that one. It's okay, Kayla. You're all right. Are you asking where I got the numbers? Okay.
So that is like a baseball calculator.
Well, I can do if it's okay. Let's do this for this next one. Let's not say any answers till I call on someone. How about that, Kayla? That way you can have a chance to push them in before somebody says it. All right. So if this is the variance, what is the standard deviation? Do not call out until I call on someone. The question is, how do I find the standard deviation if the variance is 2125? How do I find it? Yasmin?
You take the square root of 21.
That's exactly what you do. I'm going to call on someone to give me that answer, so everyone has a chance to type it in.
Write the entire decimal.
Oh, it's money. So you can go to, cents. It's money. All right. Edgar, do you have it?
$46.09.
Sounds good to me. Is it 9 cents or 10 cents? It's 10 cents? My bad, Edgar. Now, do you see how the standard deviation is $46.10? What did you guys think it was going to be? Somebody said, isn't it just 30 plus 35? Was it 65? No. So just be careful on that. All right? Always think variances add.
Would it be wrong if you put on the variances and all of that? Like, just put the dollar sign and then square?
That's fine. Yeah, you put a little square on the dollar sign. I'm cool with it. Yeah. Okay, let's do the last part here. Now we meet a couple that has 4 dogs. You have 4 dogs? Oh no. Did they make it or are they still sick?
No,
They're good now?
it's because one was found.
Oh, one was found. Okay. Who knows? All right. So we have 1 dog plus a second dog plus a third dog plus a 4th dog. So how much money are we expecting on an annual basis for this couple to spend for these 4 dogs on health care, like going to the vet? $400 is right. 100 plus 100 plus 100 plus 100. Everybody good? You got it. Yes, Zachary. All right, go grab your phone. You're going to be famous, by the way. You're on my YouTube recording. Subscribe. All right. Thank you, sir, Zachary. All right. The last one. Find the standard deviation for this couple and their healthcare costs per year for their 4 dogs. I see find standard deviation, and I think variance. So I want to find the variance of 1 dog plus 2 dogs plus a 3rd dog and a 4th dog. What's the variance for 1 dog? 30 squared is right. Plus 30 squared plus 30 squared. Now I know that 30 squared is 900. So 900 plus 900 plus 900 plus 900. Now, what you also learned in 3rd grade was that repeated addition is multiplication. So you also could do here 4 times 900. To get 3,600, and this is for you, Galilea, squared dollars. So let's find the variance. Let's find the standard deviation instead. The standard deviation for 1 dog, 2nd dog, 3rd dog, and the 4th dog is the square root of 3,600, which is $60. All right, and so the most common wrong answer I get on this question at the bottom is they take 30 and they multiply by 4, or 30 plus 30 plus 30 plus 30, and they tell me it's 120. You just found out it's not. It's $60. Okay?
Thank you so much, guys, for watching. Tune in next time for the next video. Don't forget to like and subscribe.